Good morning, students. Welcome to Good Samaritan School online classes. The last class we discussed on the importance of pH in everyday life. That we learned how plants and animal are pH sensitive and how pH is present in the soil, in digestive system, tooth decay, and how the animals and plants they are self-defensing themselves by using these chemicals. And very few have written these questions and sent to me, and I want everyone, please do the question, complete the question and send it to me at least by the end of this day. And also we learned the salt, we learned about salt, and also what is the nature of the salt also we learned yesterday, and we know how to find the nature of the salt, given salt, right? So this is what we learned in the last class, and today what we are going to learn is 2.4.3 in your book, page number 29, chemicals from common salt. As we all know that salt is formed that by the combination of acids and base, right? We know that hydrochloric acid combines with sodium hydroxide to give sodium chloride and water. This sodium chloride, that means the common salt that we are using in our home, is formed by the presence of by the mixture of hydrochloric acid and sodium hydroxide. But you have to learn one more thing. You can see here in your book, seawater contain many salts. They are not contain only sodium chloride. Sea water, that means the crude sodium chloride, is produced from the natural source, contains other undesired salts such as sodium, sodium sulfate, calcium phosphate, calcium sulfate, magnesium chloride, calcium chloride. Like all these salts are mixed together and they form, it's actually a crude sodium chloride. So that need to be extracted. So what they will do is they take that crude salt and dissolve that in a water to prepare a saturated solution. And that solution, what they do, they mix some hydrochloric acid, and through that hydrochloric acids they separate all these impurities, and only the sodium chloride, the pure sodium chloride, is separated. So once all these that means the undesired salts that I told you already, what they will do, they will be taken away or removed by filtration, and then only sodium chloride is kept out and kept out for drying, and then that is used after dried up, then it become a normal sodium chloride. This is how we use sodium chloride salt. But this sodium chloride salt is not obtained like just like that, because they have contained many salts are there in your seawater. So many processes are there. We see that evaporation is one of the process to separate seawater salt from seawater itself directly. Right, take the salt water and pour it on a place, so that after dried up we get the salt. That is one process. The second process, we have actually mining of rock salt. Rock salt will be there on the mines, as we know that coal mine, even we have salt mines also there. So from that it will be mined. And another, see that these large crystals are often brown due to impurities. This is what the impurities I told you. What are the impurities? That means they are not actually impurities, they are mixed up with other salts like sodium sulfate, calcium sulfate, magnesium sulfate, magnesium chloride, calcium chloride, like that many impurities are there. So what is this? This is actually called a rock salt, and this rock salt, it is present at the beds of these seas of bygone ages dried up. That means like many centuries, this seawater will be there, and when it dried up, they become at the under the sea. These salt will become dried up, and they become like a rock salt, hard rock. So this rock salt will be mined. That means they take that salt and they will dig the salt and they will mine it and take it out, and then purified, and that we are using in our day to day life. So this is how the salt is mined. Okay, and there is a picture also given about the Dandi March, about Gandhiji, and you know the history of this, why he is making this protest, right? Freedom struggle. Why this thing is happening? Because the British implemented tax on the salt itself. That is why the problem comes. Okay, that is not a problem now. Okay, we'll move on to the next topic. Common salt. We are going to talk about the common salt, that means sodium chloride. You know, only because of common salt, by using the common salt itself, we are getting lots of product. And you can see here, common salt thus obtained is an important raw material for various materials of daily use. As we know that how common salt is extracted, that is what we learned here, right? From the crude salt, they do lots of process, and then common salt is extracted. You know, by using that common salt itself, we are extracting on, and that common salt is one of the biggest raw material for many material that we are using in our home. Like example, sodium hydroxide. This is a baking soda which is used in our home. Washing soda, chlorine gas, hydrogen gas, or bleaching powder. You know, using this only common salt, we are preparing enough amount of things. That means that such sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. So in this chapter or in this topic, what we are going to see is, we are going to see each and every salt, how they prepared by using only sodium chloride. Okay, so from that, this is the first topic we are going to see now, is sodium hydroxide. Let's see sodium hydroxide, how it is prepared. The preparation of sodium hydroxide, the name of the process itself is said to be Chlor-Alkali process. Okay, let me tell you why this process is named as Chlor-Alkali process at the end of this topic, because you will come to know about the reason why it is named as Chlor-Alkali process. Okay, let's see what is written here. When electricity is passed through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide. Okay, so this is simply it is given like that, but this is the process how it forms. We are going to take a big it's an electrolytic tank actually. So in that tank I am going to take a brine solution. Brine solution is nothing but water. We are adding lots of salt. Salt means sodium chloride. That means in this water nearly 95% of salt is present in that. That is what actually a brine solution. That means completely a salt. In other words, we can say that the saturated solution of salt. So if I am taking this salt solution, that is sodium chloride is taken here. Once sodium chloride is mixed in this, I am going to take 2 electrodes in that, and that 2 electrodes are connected with positive and negative. And we know that what is positive? Positives are always anode and negative is always cathode. Okay, and I put some I invert some tube here so that we can identify the gas comes out through the tube. Okay, positive is anode, negative is cathode. Okay, so once the water is mixed inside the, or sodium chloride is mixed inside the solution, so what are the things, ions formed in the solution? We have Na plus, Cl minus, and then H plus, OH negative ion, like that. Not only one or two, we have enough amount of this. Cl minus, Na plus, H plus, OH minus, OH minus, right? So like that we have enough amount of ions are formed in the solution. It's all just moving here and there. Once the current switched on, you see that there are some positive things I have written. Na plus, Cl minus, chlorine, H plus, OH minus. All these are in the ionic form and they are all inside this solution. Okay. So once the switched on, you know what happened? These are connected with anode, positive. So positive and positive, they never go and attract. So only the positive and a negative will attract. So you can see here chlorine will get attracted towards anode and hydroxide will get attracted towards anode. Am I right? And same here in cathode, only Na plus and H plus is getting attracted. But the thing is, in cathode we have two things, right? Positive, the Na plus and H plus. Only H plus will go very fast and stick with this electrode. Why only Na plus, H plus? The reason is sodium is more reactive element. So they won't go a little faster. So but this H plus, they go and stick with that cathode. And that is what the process happening in the cathode. At cathode what is happening? H plus gains an electron and get reduced. Gaining, you know what is gaining? Gaining, you know what happens? H plus का मतलब क्या है? That means hydrogen is having atomic number 1, atomic mass 1. H plus कब आएंगे? That means once it loses the electron. After it loses that electron only, hydrogen will acquire H plus. Now hydrogen is having H plus here. That means they don't have any electron at all. So what happens here? Hydrogen, after it gains an electron. Okay. So it comes like this. Hydrogen, H plus hydrogen, it's gaining an electron and it forms H. Normal hydrogen हो जाता है. That means before it is having ion, that means H plus, and then after gaining an electron, now hydrogen becomes like this. Hydrogen atomic number 1, mass number 1, and normal hydrogen. So like that we have two hydrogens. When two hydrogen gains 2 electron and they form 2 H2 gas. So like that lots of hydrogen will be coming here, attached here, and they form hydrogen gas, and this gas comes out through this pipe. And you know how to identify the gas comes out is hydrogen by using a pop sound. Clear? Right. And now what is happening at the anode? At the anode, chlorine, you can see here lots of chlorine, negative, it goes towards, yes, it goes towards the positive. Right. So when all the chlorine, you know about chlorine, right? Chlorine is having atomic number, yes, 17, atomic mass is 35.5. 17 means 287, but this is not, this is actually chlorine, but here it is Cl minus. It means what? Minus का मतलब क्या है? It already gained an electron. That means इसका electronic configuration is 288 actually. So what happens here? Chlorine is giving out is 1 electron, losing an electron. Losing का मतलब oxidation, gaining का मतलब reduction, right? So when chlorine loses an electron, this is Cl, loses an electron and it becomes normal chlorine. Chlorine. Like that we got 2 chlorine, like that many chlorines are coming and attaching with that anode. So 2 chlorine loses 2 electron and become chlorine gas. Like that only all these chlorine gas are all coming out here and it will be separated in the other tank. Clear? So now what is happening? We have taken a brine solution, putting two electrodes in that, connected with positive and negative, anode and cathode. Once it's switched on, all the chlorine is going and searching, so that means Cl minus is going towards the anode, and then they form oxidized, and then they escapes out. And in cathode, what is happening? Hydrogen gaining an electron getting reduced, gains an electron getting reduced, and it comes out as a hydrogen gas. Now, two things are missing here. What are they? One is sodium, another is hydroxide, right? And this will remain in the solution itself. Clear? And this is formed in the overall equation. And what is the overall equation? Sodium chloride mixed with water, and this solution is actually a brine solution. When electricity is passed inside the brine solution, we got sodium hydroxide, chlorine gas, and hydrogen gas. Now tell me, what is the reason for that? The reason why they say that this process is Chlor-Alkali process? Because chlorine is formed and one alkali is formed. This is chlor and this is alkali. Alkali means what? A base. So that is why it is said to be Chlor-Alkali process. Understand all of you? Right. Let us see what are the uses of this. You can see in your book, chlorine gas is gives off at a anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. The three products are formed, produced in this process are all useful. You know what are the useful products are used here? You can see here cathode. In cathode, what is formed? Hydrogen gas is formed, right? And what is the uses of hydrogen gas? It is used as a fuel, rocket fuels. Margarine is actually it looks like a butter, and this butter like substance is formed by the hydrogenation process, okay, and it forms margarine. Fertilizers, ammonia fertilizers, hydrogens are used, right? And then in anode we have got chlorine gases coming out. And what are the uses of chlorine gas? Used in the water treatment, chlorine tablets. They are actually you put it on the swimming pools also. They used to put that chlorine tablets like a bleaching agent. For disinfectant, the many uses are given here also in your book. PVC, CFCs or pesticides, all these chlorine gases are used. Sodium hydroxide used for degreasing metals, soaps and detergents, paper making and artificial fibers. And not only that, by even when we mix these two, like sodium, hydrogen and chlorine, when they mix together, we form hydrochloric acid. And even that hydrochloric acid is used for cleaning the steel, or even ammonium chloride, medicines, cosmetic, many uses are there. And it's not only that, when chlorine and sodium hydroxide means we can take another base also, calcium hydroxide, that is used as a bleach. Even we are using this bleach in our home, bleaching powders, bleaching fabrics, right? So why I am telling this? So only by this sodium chloride, just by this sodium chloride, we prepared not only sodium hydroxide, we prepared, yes, hydrogen as well as chlorine also. So you see that how much useful this sodium chloride is, right? And this is one of the very important thing, because this question itself, the users question, uses of hydrogen, chlorine and sodium hydroxide, is one of the important question in our in this year board exam question paper. This question came. So I want everyone to study the uses carefully, because it's one of the very important question. And what is the topic we learned today? We have learned about how the salt formed and what are the impurities present in the salt and how it is getting purified, how it is getting mined, and then through this common salt what are the important products are formed, and especially sodium hydroxide. And today we learned chlor-alkali process. Yes, this is the topic we have learned today, and if you have any doubt on this, please ask questions through my WhatsApp number. Have a good day and thank you.